All right. So before we can talk about sector area and arc length and the formulas used to find them, we first need to kind of figure out, okay, what am I actually doing? All right. So a portion of a circle that is bounded or surrounded by two radii and an arc is known as a sector of a circle. All right. So when I think of sector, in real life, like say, if you're military, there's different sectors of the military, specifically in the Department of Defense, which basically just means different departments. All right. Or a piece of a whole. Same thing with circles. Sectors are literally just a piece of a whole. So, we're working on finding different types of sectors, and there's two different types. So there's the area and arc length of a sector. So there's sector area and then the length or arc length of that specific sector. So for the first exercise, they said that circle O has a radius of 12 inches and the sector is defined by the two radii OB and OA. The central angle is 60 degrees. So in geometry, this is known as a minor sector created by the two radii. Now, this is review from Unit 6. Why is this called a minor sector? So measures less than 180. Measures less than 180, good. So, recall from Unit 6, central angle, if we actually found the measure of the arc, like the degree of the arc, it would also be what? 60 degrees. All right. So, since it is less than 180, we have to assume that it's a minor sector. All right. So, minor, all it means is that it's less than 180 degrees. Now, before we can determine the sector area or the arc length, we first need to find what the circumference is, so what the original perimeter of a circle is, and what the area of the full circle is. All right? So, who remembers the formula for circumference of a circle?
Yes.
Nope. That's area.
The base and the height times 1/2.
That's triangle.
What does it start with?
There's a pi in it somewhere. That's area. 2 pi r. So the circumference of a circle is 2 pi r. Or it's just the diameter times pi, depending on what you're using. But in this class, we're going to use 2 pi r. All right. So,
Yes. First periods test any glitches before I hit print? No. Everything was good? Okay. What are we learning about today? Just legal?
As guy.
Do you know what this is? A not quite accurate slice of pizza. Right. You're welcome. How many slices of pizza would this make if all the slices were 60 degrees?
8.
No, because 8 times 6 is not 360.
Oh.
6. What is the slice of pizza you eat?
We just pizzas.
They cut it into 8 slices. So what angle is that? 40. No, you're
30.
close.
30.
I heard it.
50.
No,
45.
25. Every time you eat a slice of pizza, you're eating.
Yeah, that's it. All right. Okay, so hush. So before we can find a fraction of each, we first need to find the whole. So how would I set up for the circumference of a circle? So how would I set up or plug in, or what will I plug in into my formula for circumference of a circle, Jason?
Oh, good. I won't question one. Repeat the question.
So what am I plugging into this formula?
12 and 60.
Just 12.
Oh, 12.
Yeah. We just need the radius. So the radius is equal to 12. So we have 2 pi times 12.
That would be
And they want us to express our answers in both pi and to the nearest hundredth. So does anyone remember how I just expressed in pi? So we did this when we were doing all the
2 pi
volume.
times 12. Or just 2 pi.
We would just do 2 times 12, slap a pi on at the end. So this would be, the circumference would equal 24 pi. Or, so if you put that in your calculator, what is it approximately to 2 decimal places? So do 75.40. And with that, Camden, you have reached your quota for answering questions today.
Yes, finally, Greg.
Well, just because he's getting it right, I want to give other people a chance.
Thank you. Oh, sorry. Yeah, I didn't mean that.
All right, so this is the actual, this is the approximate. Both have their own merits. All right. So what would I be plugging in for area of the circle, Emery? So that's the only thing I gotta plug in to the formula. So for this formula, what's the only value I gotta plug in? 12. So I have pi times 12 squared, which, anyone, what's 12 squared? 144. So my area would equal 144 pi, or if you guys plug that in your calculator, what is it to 2 decimal places? 452.30?
No,
40. Guys, hush. Guys, stop talking, please. Hush. All right. So, what portion or fraction of the circle's area and circumference are contained in the shaded sector? Explain how you know this answer. So, this is where the activity that we did in the Desmos classroom kind of comes into play. So, we're kind of going backwards. So, before you found the fraction first, and then you figured the angle out based off of the fraction. Now we're going backwards. We know the angle, so how can I find the fraction? So in other words, how much of that whole do I have?
60.
We have 60 degrees out of 360. So what fraction do I have?
So 60 over 160.
Right. So it'd be 60 over 360, which simplifies down to what? 1/6. Good. Shh. So this is how much of the circumference and the area that we'll be finding. All right. So now that we know that we have 1/6 of the circle, so we have 1/6 of the circle shaded. Now we can find that arc length and that sector area. So using what I got in B and C, all right, what do you think I would do to find the arc length or the portion of the circumference for this particular sector? So I'm finding just the length of this right here. What do you think I would do, Paula? So think about it logically. I know what the whole is. I know what fraction I'm trying to find. So what do you think I'm going to do? Right, that's exactly what you would do. So you would multiply your circumference by 1/6. So for AB, or the arc length, we're going to do 24 pi over 1 times 1 over 6. So what's 24 pi times 1? 24 pi. What's 1 times 6? 6. Now, if I simplify that, what's 24 divided by 6? 4. So our arc length is 4 pi. All right, what is it approximately? 12.2 decimal places? 5.7 inches. So this right here is our arc length. Which, remember, arc length is just the piece of the circumference. All right. Now, if I want to find the sector of AOB, so that's the shaded sector, if I want to find the area of that sector, what do you think I'm going to do, knowing the whole and the fraction I'm trying to find, Alexa? So I found the arc length. Now I'm going to find the sector area. So I know what the whole area is, and I know what fraction I'm trying to find. So what do you think I'm going to do? What did I do with arc length? Multiply. So what do you think I'm going to do with sector area? Multiply. So I'm going to take 144 pi, put it over 1, and multiply 1/6 to it. All right. So this would be 144 pi over 6. All right. And what's 144 divided by 6? Anyone?
18.
24. Jason, there's this thing called a calculator. Try it. So 24 pi inches squared is your total sector area. What is it approximately? 75.39 inches squared. So this right here is our sector area, which again, the sector area is the piece of the area. So guys, even without knowing what the formula for sector area and arc length are, you pretty much got it. All right. All you do is just figure out how much. You first figure out what the whole circumference and the whole area is. You then figure out how big of the circle your degree is. So you just take that, divide by 360 to get your fraction, and then multiply that fraction to your whole. You get your answer. All right. So even without knowing what the formula is, we already derived it. All right. So in other words, if you don't remember the formula, that's okay. Because if you know that, okay, I know what the whole is, or I can easily find the whole, I know what the, I know what I said. Whole with a W. Keep your mind out of the gutter. So we know what the whole area of the circle is. We know what the whole circumference is. Then we just find what the fraction of the circle is that we have. So we just take that angle, divide by 360, because 360 is the whole of the circle, degree-wise. And then, I'm going to throw my pen to Jason, I swear. And then you just multiply that fraction to our whole, and we get the fraction that we want.
Do it.
All right, so let's just take what we just did and see if we can try another one. So, a patio is a shaped circular sector of a radius of 20 feet and the central angle is 110. They want to know the area of the sector to the nearest square foot. All right. So, first off, we're finding sector area. So, what should I find for the circle first? We're finding sector area. The area of the circle. So, you need what the whole area of the circle is. So, we're going to do pi r squared. So, what's my r? 20. So, I'm going to do a is equal to pi times 20 squared. What's 20 squared? 400. So A is equal to 400 pi feet squared. And I'm just going to leave it in terms of pi because I want my answer to be as exact as possible. Now, I need to figure out how much of this circle 110 degrees is. So how much of the circle is 110 degrees? How do I find that? Divide 110 by 360. So what would that be as a simplified fraction? So if you put in your calculator and hit math, enter, it'd be 11 over 36. Now, in order to find my sector area, so my total area is 400 pi. I want to find 11/36 of it. So how would I do that? So 400 pi over 1 times 11 over 36. So do 400 times 11. 4,400. That is true. You did beat your quota. Over 36. Now, do 4,400 divided by 36, and if it's a fraction, just simplify it.
$2,200 over 3.
Good. So this would be 2,200? 100 over 9. Yeah, that makes a bit more. So it'd be 100 pi over 9 feet squared. 1,100. Now, that is our exact. So, heads up, guys. Come on. Either heads up or you're going to be standing up. So, this is my exact sector area. But it also wants. Well, if you ask me, it's not going to happen until the end of class. So, that's our exact, but it also said it wants it rounded to the nearest foot. So what would it be to the nearest foot? So if you put in your calculator, someone who has not talked yet, tell me what it would be to the nearest foot approximately. So all I gotta do is just type in 100 or 1100 pi and then divide it by 9. Make sure you put parentheses around the 1100 pi if you're typing it all in at once. So someone who has not yet talked today, what would it be approximately to the nearest whole number? Whole number. So it would be 384 feet approximately. So this is our approximate answer. All right. Any questions? All right. So take a minute and solve the next one. So even though it's not the full circle, all right, it's just the sector. So imagine that is within a full circle. So they gave you for this next one, they gave you the sector, but in reality, and that's not a good circle, but it's of a full circle. All right. So use what you know and answer the question for exercise 3. So I'm gonna give you guys about let's do 5 minutes and see where we're at. Shh. So at the very least, just to kind of give you guys hush. So just to kind of get you guys thinking about it. They want this area surrounded by fencing. So in reality, are you finding sector area or are you finding arc length? Arc length. If it's surrounded by fencing, they want to know how much fencing. So it's the outside of it. All right, so you need the arc length. So it's the same process as sector area, but instead of finding the area first, you find the circumference.
Well, how can we find the circumference if we don't?
Well, you got the radius, and that's all you need. Ooh. Yes.
Yo, mother did. Hey, watch your mouth.
So she'll be
Reduced. It's 34.
she's in 9th grade. It's literally like across the Shh. Independent work. I should not be hearing talking. Once Fatima gets back, you can go. Well, so you're going to pi r. So I'm going to use pi. So, are you done? Are you done with pi? Can I correct you, God? I finished. I just did my correction.
See.
Is that right? Oh, I did it wrong.
Yeah, we did it.
Here, I'm done. Shh.
Yeah, that's what we have.
Shh.
I just did what we just did.
Why have that? We can have that.
Supposed to be circumference. I'm not making circumference area. Wait, so that's the two. That's 2 pi. Oh, so it was just it's the same. All right. Yes, you do it all.
But yeah,
And then you add on to the other.
yeah, I was doing it.
You're finding the whole.
Wait, so it's a, never mind.
So. Oh, I didn't do that. See
Wait, you got 115. You don't square it. You gotta add.
Oh.
You add 100 to the stuff surrounding the whole fence. You add 200 for the two.
Oh. All right, guys, let's talk about this. Okay. So even if you didn't get it, it's okay. We'll walk it through together. All right. So let's go with. So a garden has a shape of a circular sector with straight sides that measure 50 feet in length and a central angle of 132. The garden needs to be surrounded by fencing. How many feet of it are needed? And wants us to round to the nearest foot. So I already said if we're surrounding by fencing, it's not asking how big the garden is. It's asking how much fencing we need. So remember, like way back in middle school when you all would do like simple area of like rectangles, typically like or perimeter rectangles, you would see like the fencing problems, like how much fencing, that typically meant perimeter. So in this case, we're talking about circumference or arc length. So yes, some of you guys were doing the process correctly, but you were doing sector area instead of arc length. All right, so make sure you know the distinction between the two. All right. So Socorro, if I'm finding, what would be my first step to solving this? So the radius is 50. Then what would I do with it? So I'd find the whole circumference first. So 2 pi times 50. And what'd you get, Socorro, for it? All right. So what about if it was just in terms of pi? So in other words, I just have to multiply the 2 and the 50 and slap a pi on it at the end. 100. So my circumference would be 100 pi. I'm just going to leave it like that because I want it to be as accurate as possible. All right. So Socorro, pick someone to tell me the next step. All right, Ziamara, what's my next step? So I found the circumference. Now what do I need to do?
What do you do? 360? No?
No, you're on the right track. Keep going.
Over 100? Or 150?
So I need to find how much of the circle 132 is. So you,
132 over 360.
there you go. So I would then do 132 over 360, which what would that be as a simplified fraction? I mean, you could do it in your calculator. So just do one.
Over, wait, give me a second, please. 11
So it's just 11.
over 30.
So 11 over 30. All right. So this is how much of the circumference we want. Shh. All right. Ziamara, pick someone to give me the next step. All right. Paula, what's my next step?
So 100
Mm-hmm.
over 1 multiplied by 11.
Good. And what did you end up getting? So simplified, what'd you get? Okay, so you should have gone about 110 over 3 pi. Yeah, 110 doesn't go into 3. All right, so this is your exact arc length. So what would it be approximately? Paula, pick someone to tell me that.
Just pick someone for a lesson.
All right, so what is my approximate arc length? 115 feet if we rounded. Now, is that my answer? No, because the only piece of the fence that we covered is this piece right here. So this is 115 feet. But I want the fencing amount for the entire garden. So, Alexa, tell me someone to tell me what I need to do next. All right, so Sophia, what do I need to do to finish it? Right. So we would add the other 250s to my answer to get my final answer. So in other words, we're just adding 100 to 115. So I should get approximately 215 feet for the entire garden. So this is the arc length. But because we want the entire garden, we got to add 100 to it, which is just 50 plus 50. Any questions on that one? All right. Now, sometimes they may have you work backwards. All right. So let's look at example 4 together. So it says a sector of a circle whose radius is 5 centimeters and has an area of 20 centimeters. Is the central angle of this sector acute or obtuse? All right, so it's saying the sector of the circle has a radius of 5 and an area of 20. So always draw a picture to kind of start out. So we have a circle, and there's some sector, and I'm not drawing it to scale, where the radius is 5 centimeters. And the area of this sector is 20 centimeters squared. So before we can decide whether the angle is acute or obtuse, we first need to kind of find the angle. All right. Now, we don't know what the area of the circle is yet. We only know what the sector area of the circle is. However, can we find the area of the circle? Yeah, don't we have enough information to find the area of the whole circle? Yeah, because we have the radius, so thus we have enough information to do pi r squared. So area would equal pi times 5 squared, which is just 25 pi. I'm going to leave it like that. So this is my total area. Now, this is similar to the Desmos classroom activity. All right, we have the total area, we have a section of the area. We want to figure out how big of an angle we need. So think back to what we did through the Desmos classroom activity. So think about for a second about our next move. What do you think I'm going to do next, Maria? Well, think about it. If we got the whole and we got a piece of it, don't we need to figure out how big this piece is first? How do you think I'm going to do that? So I got the whole area and the piece of the area. Divide it. So what would I divide by? So like how would I set up my division? So I would do 20 divided by 25 pi and then simplify it. All right. As best as possible. So I'm going to do 20 over 25 pi because that's the amount of the fraction that I have of the area. So if I simplify that, it would just be 4/5 pi. I'll just leave it like that. So this is my fraction of the area. Now, I need to find the angle that makes it. All right. So if I have the fraction of the area, what did we do after that in our Desmos classroom activity to find the angle measure? Harris. So in our Desmos classroom activity, after we found the fraction of the piece of the pie, how do we find the angle measure? We want that same fraction, but out of what? 360. So how do you think I'm going to find it? My desk. Wouldn't we just, what operation would we do between that fraction and 360? We would multiply it. So I'm going to take 4/5 pi and multiply it by 360 to figure out how much of it. Now, we're not going to get a pretty answer for this, so just put that in your calculator and round. And make sure that this is in parentheses and that's in parentheses. So do 4 divided by 5 pi and times it by 360 and give me an approximate.
.67.
Oh, wait.
0.67.
Yeah. 91.67 degrees. So, based off of that angle measure, is the sector or the central angle of the sector acute or obtuse? It's obtuse. It's greater than 180. Or not, no, it's greater than 90, sorry. So, this would be an obtuse angle. All right. Try the last problem, similar to the one we just did. Try the last problem on your own. Make sure you read it carefully. Make sure you're finding the correct thing, whether it's area or circumference. But you just gotta figure out whether it's talking about arclight or sector. So think about it. So the horse is attached to a rope that's 8 feet long. So let's say the horse is right here, and it's walking around. It'll walk around 28 feet.
Is it in the area?
So we're finding how far circumference. So it'll be so you find the circumference first, and then use the arc length.
So this is 2, 5,
It's 2 pi r's and pi r's.
So guys, once we finish this problem, I'll let you guys go on break. You look like this. So we're just gonna back to page 6. And I'm recording this.
Oh, shoot. Okay. So,
Is it 2 pi r's? It's not. It's not.
So guys, shh.
It's not.
That's the circumference. Now you need to figure out what angle or what portion.
hey, touch me, speaker. Ready?
Can you assess my paper?
We're about to go on break.
Really?
Assess my paper. Foot square.
Yeah, you're going back. And we know what the arc length is, which is 28. So how much of 28, or how much of 16 pi is 28? So do 28 divided by 16. You need that fraction.
Just crash on.
And then you multiply by 3.
Yeah. Just crash on. That's very July, didn't it?
After that.
Yes. We'll go over it.
I didn't know that.
7, 7, and then 4 pi.
And now multiply that by 360.
What'd you get? I didn't. That's what I got.
Nobody.
It is. I think
That's how bad it is.
All right. All right. So, first off, it says a horse attached to an 8-foot rope. So, basically, if you put a stake in the ground, which is the center of the circle, and the horse is attached to the rope, the horse would be right here. It said that the horse walked around in a circle. So, if the horse is pulling the rope taut and just walking around, he'd technically be walking around in a circle, and the horse walked 28 feet. So first off, is that going to be the arc length or the sector area? Arc length. So this 28 is our arc length. And it wants to know at what angle can the horse walk about. All right. So we're finding this angle right here. So if I'm finding arc length, am I finding the, do I need to find the circumference first or the area first? Circumference. So guys, I'll give you a hint. Sector area, if you're given the sector area, it's in the name. You find area first. All right. Arc length is circumference. Okay. So, Jason, you said area. You can't talk.
I think actually.
So we're doing 2 pi r. So what's my radius? 8. So my circumference is 2 pi times 8. So just 16 pi. Now, this is my whole circle. So in other words, if we made a whole circle of fencing, there would be about 16 pi worth of fencing. Now, I now need to figure out how much of my circle 28 feet is. So how do I do that?
28 divided by 16 pi.
Right. I need to do 28 divided by 16 pi because I know that 28 is a piece of 16 pi. All right.
Which is 7/4 pi.
So that simplifies down to 7/4 pi. So hush. So this is a piece of the whole. That's how big of a piece it is. It's 7/4 pi. Now, I then need to find the piece of the whole, but in terms of degrees or the angle. So what's my last step? Multiply it by 360. So I do 7/4 pi times 360. So it's 200.54, so that'll be 201 degrees, approximately.
Are you? Stop giving nasty.
All right, so I didn't exactly give y'all your break today, so I'll let you guys, if you need to use the restroom now, you can go ahead. This will be the end of notes for today. There is a delta math on this. You should have enough information to do it now.